Okay, we're learning about the Pythagorean identity, and what we're going to try now is to start with the Pythagorean identity and prove the Pythagorean theorem. Remember, what we did in the earlier example was we started with the Pythagorean theorem and we proved the Pythagorean identity. So the point of this is to show that you can get from one to the other or from the other back to the first one, and so that the two facts are really equivalent, even though one sort of seems like a geometric fact and one seems like a trigonometric fact. So let's do that. Remember, the Pythagorean identity says that sine squared x plus cosine squared x is equal to 1. And the Pythagorean theorem, that's a theorem about right triangles. So let me set up a right triangle here. And I'll label the sides A, B, and C. That's the Pythagorean identity. Now I'm going to use my SOHCAHTOA. So SOHCAHTOA tells us that if we have an angle here, I'll call this angle x in the corner here, the sine of x is equal to the opposite side over the hypotenuse. So the opposite side here is b over c. The cosine of x is equal to a over c, the adjacent side over the hypotenuse. So I'm going to plug those into the Pythagorean identity, because remember, we're allowed to use the Pythagorean identity here. So that says that sine squared x plus cosine squared x equals 1. If I plug those in, I get b over c squared plus a over c squared is equal to 1. And now I'm just going to do a little bit of algebraic manipulation. B squared over c squared plus a squared over c squared is equal to 1. I'm going to multiply both sides there by c squared. And so that'll clear my denominators on the left. I get b squared plus a squared. And on the right, I get c squared. And if I just switch around the two terms here, a squared plus b squared is equal to c squared. And so that is the very familiar equation. We have proved the Pythagorean theorem. So we started out with the Pythagorean identity from trigonometry, and we ended up proving the Pythagorean theorem from geometry. A squared plus b squared equals c squared. So it's just a matter of writing down the right angle in one corner of a triangle and then working through the algebra. You end up with the Pythagorean theorem from geometry. So that shows that the Pythagorean identity and the Pythagorean theorem really are equivalent to each other. You ought to be able to start with either one and prove the other one.